Okay, so now we're going to get into some trigonometry here. And this is actually quite fun, so let's take a look at what we've got. So in the first problem statement, it says suppose that theta, so this right here is theta and it represents an angle. Suppose that theta is in standard position and the given point is on the terminal side of theta. So the point that they give us here in this example, 3, 4, is basically on the ending of the angle. Okay, so just think about that for a second. If you were to draw like a ray coming from the origin to the point 3, 4, uh, it might look something like this. So let me go ahead and give just a rough sketch so that you know what it looks like. So 1, 2, 3, and up 1, 2, 3, 4. So suppose it looks something like this coming from the origin, maybe not the best sketch, but it's some angle that looks like that, theta. So that's what we're looking at here. In this case, they ask us to find the sine of theta. Well, the trick for this is that there's a formula. And it says that the sine of theta is equal to y over r. Well, we know this right here is x and this right here is y, but we don't know what r is. So let's figure that out. Okay? So all we have to do is say, well, x squared plus y squared. And let's think about this. We have here the x component and we have here the y component. So if you have basically a triangle, x squared plus y squared gives you r squared. And that basically in a nutshell is exactly the Pythagorean theorem. Okay, so let's take a look then. Here's x, here's y. So I'm going to say r then is going to be the square root of 3 squared plus 4 squared. And this right here we know to be 9 and 16. So this is 9, this is 16, and we're going to add them. So the square root of 25, which is 5. So in this case, r equals 5. And so really simply put, if we have r equal to 5, and sine of theta, based on this notation here, is y over r, then in this case, sine of theta will equal, y was 4, and r is 5, so sine theta equals 4/5. So it looks something like this. Okay, so pretty simple. All right, now let's take a look at the next example. It says the cosecant of theta. So the cosecant is r divided by y. And again, we're given x, we're given y, but we don't know r, so we're going to calculate it with the same formula up here. All right, so in this case, r will equal the square root of 9 squared plus 12 squared, which in this case is 81 plus 144. And this gives us then the square root of 225, which we know to be 15. So r equals 15 in this case. All right, so the cosecant of theta, which we said over here was r divided by y, is going to be 15 divided by 12. And you, of course, can reduce this, and it becomes 5/4. So that's what that looks like. So the cosecant here is going to be 5/4. All right, and then let's take a look at this very last example here at the bottom. We have the cotangent of theta. So again, I'm going to label x. I'm going to label y. And we know from this notation here that the cotangent of theta is x divided by y, so long as y is not equal to 0. So in this case, let's see what we've got. We've got x divided by y, so cotangent of theta will equal x divided by y, which is 0 divided by 9. Y, of course, is not 0, and this is actually negative 9, sorry. So 0 divided by negative 9, which is just 0. So this one right here, very simple. The cotangent of theta is simply 0. And so really quite easy, quite simple examples here. And we just kind of have to know these formulas here. And of course, the main ingredient in all of this is that r equals the square root of x squared plus y squared. But if you look at this very simple diagram, you see that it's just all based off of the Pythagorean theorem.